Now, today we're going to be discussing a recently published paper titled The Effect of Relative Encoding on Memory-Based Judgments by Marissa Sharif and Daniel Oppenheimer. Now, the authors start off by discussing how research has shown that we are bad at identifying or estimating the absolute magnitude or total quantity of a stimulus, but we are good at discriminating stimuli from one another. For example, it is difficult for people to accurately identify the number of dots within a given pattern, but we are very good at figuring out which pattern has more dots. For instance, if I quickly present you with this image, and I ask you to tell me how many dots were in figure B, you may not be able to do so very quickly. But if I quickly flash this same image, and I ask you to tell me which figure has more dots, you may be able to quickly identify pattern B as having more dots than pattern A. Now, related to this point, other research has shown that when assessing a stimulus, people represent where in a distribution that stimulus lies rather than the absolute value of the stimulus by making either an ordinal judgment or making either an interval judgment. Now, an ordinal judgment suggests that people can determine which stimulus is better, but not by how much, while an interval judgment refers to the idea that people can determine how much stimuli differ from one another, but in relative terms and not in absolute standards. Now, essentially, what this is saying is that people's evaluations are heavily influenced by their surroundings. Now, to further demonstrate this point, that people's evaluations are heavily influenced by the surrounding stimuli, we can look at a commonly used circle illusion within psychology. Now, despite these orange circles being the exact same size, the circle on the right looks much larger than the circle on the left. Now, this is because we tend to judge circles as being smaller when they are surrounded by larger circles. Now, the takeaway from this message is that our judgments are informed by relative rather than absolute standards. Now, although our judgments are often informed by relative rather than absolute information, there are times in which we must make a decision without the help of readily available information. Put simply, it is not uncommon for our judgments to rely on our memories of past information. Now, prior research has shown that when we rely on our memories to help us with a given decision, we rely on our initial impressions of those past evaluations, and we tend to be more efficient in doing this than recalling the details of that past evaluation and then reevaluating all of our options. Now, if our judgments are relative rather than absolute, and if we rely on our initial impressions of stimuli, then do our evaluations of prior stimulus change after we acquire new relative information? Now, the authors discuss a relevant example related to this point, in which there is a college student who eats mainly dorm food. However, the student is able to occasionally go out to a local pub, and the food that the student eats at this pub is among the best food that the student's ever had. Now, eventually, the student graduates and is exposed to a variety of new food sources that are likely to be much better than the original pub food. Now, given the exposure to new, better food, how would the student recall the quality of the food from the pub? Well, to try and answer this question, the authors conducted a series of studies. Now, in the first study, the researchers had participants listen to several song clips at 2 different times and then make evaluations about who they thought was the best singer and who they thought was the worst singer. Now, in this study, the researchers had 2 very bad singers, they had 3 average singers, and they had 2 very good singers. Now, participants were randomly assigned to one of 2 conditions. In the first condition, which the researchers called the T1 top condition, participants listened to 2 bad singers and then they listened to an average singer. But in the second condition, which the researchers called the T1 bottom condition, the researchers had participants listen to 2 good singers and then listen to an average singer. Now, the reason for doing this was to make the average singer look relatively good or bad by comparison. Now, after listening to these individuals, the participants completed a distractor task and were then asked to listen to 2 more average singers and were then asked to select one singer to be the winner and one singer to be eliminated. Now, as you can see in the graph, when the average singer was paired with a bad singer, or in the T1 top condition, the average singer was frequently selected to be the winner. However, when the average singer was paired with the good singer, as we see here in the T1 bottom condition, the average singer was frequently selected for elimination. Now, essentially, the results from this study demonstrate that the evaluation of the average singer depended on his or her relative comparison to either the very good or the very bad singer, and our initial relative evaluations of a given stimuli do not change even after we are presented with new information, such as the presence of an additional average singer. Now, in the second study, the researchers had participants watch toy cars race along the track at 2 different times and then make evaluations about which car they thought was the fastest. Now, in this study, the researchers had 3 different toy cars consisting of a slower red car, a faster yellow car, and a moderate speed black car, which they called the target car. Now, similar to the first study, the participants were randomly assigned to one of 2 conditions, in which they either saw the moderate car race the slower car in the T1 top condition, or they saw the moderate car race the fast car in the T1 bottom condition. Now again, the reason for doing this was to make the moderate car look relatively fast when racing the slow car, or to look relatively slow when racing the fast car. Now, after watching the 2 cars race, participants completed a distracted task and then were asked to race an additional car race along the track. Now, although they were told that the final car was a different car, it was actually the same moderate speed black car that they saw before, and the researchers consider this to be a decoy car. Now, participants were then asked to rank the 3 cars according to speed, according to how fast they thought they were going. Now, as you can see in this graph, for the second study, when the moderate speed car was paired with the slower car, like we see here in the T1 top condition, the participants rated it as being the fastest. However, when the moderate speed car was paired with the fast car, here in the T1 bottom condition, we see that the participants rated it as being the slowest. Again, the reason for doing this, the results demonstrate that our earlier evaluations of a given stimuli, such as the speed of a toy car, are dependent on our earlier evaluations. Now, in their third and final study, the authors had participants record the number of butterflies that landed on certain flowers. Now, these butterflies and flowers were not real, but instead were aspects of a computer program. Now, for the sake of time, I'm not going to be going into the specifics of this study, but I should point out that the results were essentially the same in study 1 as they were in study 2. And, and the participants relied on their memories to make relative judgments. Now, as we discussed earlier, prior research has shown that people encode information relative to the context that they're in, and when making judgments from memory, people tend to rely on their initial impressions. However, given that the current study was able to demonstrate that people rely on initial evaluations of a given stimuli, even when the contextual information has changed at time 2. Now, in 3 separate experiments, people encoded information relative to the context at time 1. For example, the average singer was presented with either a very good or a very bad singer at time 1, or a moderately fast car was paired with either a slower or a faster car at time 1. Now, across all 3 studies, the researchers found that participants would not update their decisions or their evaluations after being presented with new information. Specifically, the average singer was seen as being the best when compared initially to bad singers, but was seen as the worst when initially compared to good singers, despite being presented with new information at time 2. In addition, the average car was seen as the fastest when initially compared to a slower car, but was seen as the slowest when initially compared to a fast car, again, despite being presented with more information at time 2. Now, in sum, when making memory-based judgments, we tend to rely on the context in which the original stimuli was encoded. Furthermore, it is important that we are aware of this bias. because our initial evaluations may bias how we encode later information. Now, given that many of our judgments are based on memory, additional research is needed to understand how and why people make biased judgments and decisions.